The last two groups that need to be named would be the molecular compounds and acids. We're going to start with the molecular compounds. Now the molecular compounds would be things like CO2, carbon dioxide, CH4, which is methane, BCl3, boron, trichloride. These are all formed from two or more nonmetals bonded together, so you won't see any metal in any of these formulas. Now, remember and recall that ionic compounds generally have a metal in them, and then they also have a nonmetal. So we're talking about two elements, or two or more elements that come from the far right in the periodic table combining. These are the molecular compounds, and these are the rules that apply. Very, very simple rules, actually. It's a prefix system. Usually the less electronegative element is written first. Now, we've not talked about electronegativity yet, but generally what that means in the periodic table is the element is usually farther to the left. So whichever element in the nonmetal section kind of comes first in the periodic table, left-right speaking, generally comes first. And then up and down in a group, generally it's whichever element is farthest down in a group. So you add prefixes then to indicate the number of atoms. We don't use mono on the first element. We do use mono on the second element. So the prefixes then indicate how many atoms there are, and those are indicated by the subscripts in the compound. And then the ending, of course, just like with our binary ionic compounds, the ending then would be IDE. Now, in order to name these compounds, we must know the prefixes. So this is a table of prefixes that you're expected to know. So if there's a single atom, mono, two atoms, di, three atoms, tri, and so on there. So let's take some examples. I would jot this table down in your notes for sure, and you are expected to know all the way through 10, although we could keep going beyond 10 if we wanted to. Let's take these three examples. So the first example there is CCl4. So there's a single carbon and then 4 chlorines. So a single carbon, you would just simply write carbon, or you could put monocarbon. And then there are 4 Cls. The prefix for 4 is tetra, and then chlorine needs to end in IDE, so carbon, and then tetra, and then chloride. So this would be carbon tetrachloride, and that would be 2 words. Second example, N2O. So the first element is nitrogen, so we just write it as nitrogen, except there are 2 of them, as indicated by the subscript, so we need di in front, so dinitrogen. And then there's a single oxygen. You need it to end in IDE, so that would be oxide. There's a single oxygen, so we need to put mono. And then just for simplicity's sake, we leave out one of the O's. So instead of saying monoxide, we just say monoxide. So this compound would be named dinitrogen, 2 nitrogen, and then monoxide. Now notice in the first 2 examples, we've not done anything with charges. So there's no charges involved in here at all. We're just simply looking at the subscripts and using the prefixes. Last example, single sulfur, so just sulfur, 6 fluorine with an ending IDE, so sulfur, 6 is hexa, and then fluoride, and again it's 2 words, so that would be sulfur hexafluoride. So let's go in the other direction then and try writing the formulas. So let's take this first one, arsenic, and notice there's no prefix, so that just means it's a single arsenic. So AS would be the symbol, and then notice that it's trichloride, so Cl would be the symbol for chlorine, and then there's 3 chlorines, so the subscript would be 3. So the formula there would be AsCl3. AsCl3. Second example, notice it says dinitrogen, so that simply means 2 nitrogens. And then pentoxide means 5 oxygen. Pent is 5, oxide is oxygen. So then N2, dinitrogen, O5, pentoxide. Last example there is tetraphosphorus dicoxide. Notice that there's P4, 4 phosphorus, and then docoxide means 10 oxygen, so P4O10. Now, I would pause here and try these 5 examples. Fill in the blank, whatever's missing, whether it be prefix or the actual name, and then we'll move on to the second learning check. So pause here and try these. Second learning check. Second learning check, they're given the formula and you're asked to come up with the name. Multiple choice there, so make your choices appropriately. And again, I would pause here and actually try it. Be careful with number 3. Number 3 is a little tricky. Now, overall strategy for naming chemical compounds. Thought it was important that we kind of combined everything in some kind of flowchart thing. If you have a binary compound that has 2 elements, you need to figure out where to go. So, is it a binary compound? Does it have 2 elements? If it does, yes, then you're going to go to a separate chart. If it doesn't, then you need to find out, does it have a polyatomic ion present in it? If it does have a polyatomic ion, then you're going to name the compound using the rules that we went over with polyatomic ions. If it has no polyatomic ion, and it's not a binary compound, then that means it's a whole different issue, and those are compounds that we haven't quite named yet. So figure out whether it's binary or not binary first. Now, if it is a binary compound, does it have a metal in it? And if it has a metal in it, then you need to determine whether it has a transition metal, because if it has a transition metal, you need to use a Roman numeral in the name. If it does not have a metal present, then you're simply using the prefixes that we just discussed. So this flowchart and the previous flowchart are supposed to help you stepwise figure out which set of rules you should be following. Okay, so let's use these 2 charts that you've jotted down, and let's try a review of everything that we've learned to name and write formulas for so far. So let's take these 3, and you may want to pause here and try the 3 of them. See if you can come up with the correct names. And then the next slide is going to give you the solution. So I would pause here and try these 3. Now here are the solutions then to the 3 of them. So the first one was calcium oxide, binary compound, metal is present. The second one, again, binary compound, metal is present, but it's a transition metal, so Roman numerals are required there. And then finally, that last compound, 2 nonmetals, so you don't need to worry about transition metal there. And because it's 2 nonmetals, you just simply use the prefixes in the name. Now this next slide is another set of practice problems. So again, I would pause here and I would try all of these. Another set of practice, 9 of them there. I would stop here and again use your flowchart if you're having trouble figuring out how to name them. I would try these 9, so pause here.